So let's do our usual. So I get things going. We have another treat tonight. Boris is going to talk about the Arc of AI conference in a little bit. So, all right, let's get going. There we go. All right. So our standard agenda, if you've been here before, you know we thank our sponsors. We talk about what's new. I'm going to introduce Ken, and then we'll have the main presentation. And I'll come back and do what's coming up and whatnot. So of course, Payara, they use a middleware for their application server. They're our gold sponsor, so we thank them and appreciate their support. And Azul is our silver sponsor. Of course, they are a downstream distribution of OpenJDK. We partner with DevNexus, so we're involved, and if we're lucky enough to get our abstract accepted, we'll give a presentation there. That's between Chandra, Barry, myself, and there's also a Java user group leader summit they have, and then also a Java champion summit. So we're really involved in those efforts. Our per meeting sponsors, okay, as you know, JetBrains, they make all those IDEs for Java, for HTML, for C#, you name it, right? Romanelli's is the local pizzeria here from which we have our pizzas. And then, of course, Jakarta EE, or more accurately, the Eclipse Foundation, they provide Crowdcast hosting for all Java user groups. Now, you might be saying, Mike, how come we're not using that? We decided to go with Zoom and YouTube, but I want to at least acknowledge them for what they do. And of course, Honeycomb IO is the April 2025 sponsor. Ken said he would pick up the pizza cost tonight, so thank you, Ken. We appreciate that. Okay, so real quick, our memberships, you've seen this before. Jakarta EE ambassadors, Jakarta EE my profile, and the virtual jug. All right. You've seen these before. This is a Jakarta EE future directions group. This is Jakarta EE 12 and beyond. So myself and representing the Garden State Jug, I am part of this group. So we talk about some ideas on what kind of new specifications can come out, those kinds of things. So there's a lot of talk about AI, but it hasn't been created yet. So that'll be coming at some point. Jakarta EE ambassadors used to be the Java EE guardians, going back to the days when it took forever to get Java EE 8 out. So, all right. Let's see. What's new? All right. We had an awesome Java 1 2025, last month, and we were fresh back from DevNexus. So myself and Chandra gave presentations out there. We had a Java Luminary Summit. All the Java champions were invited and to interact with all the high-end Oracle guys. So that was fun. Let's see. The Payara podcast, I told you about that. They also, since they're hosting a number of Java user groups, they did one with the Torino Jug out of Italy. And I didn't put the link on there, but they did Chicago Jug and another one together, maybe Seattle. I'm not 100% sure, but I'll have to add that for next time. All right. Java 24 is released on March 18th. Okay. So there's 24 new features, and you've seen me have those JEPs written on in the past. Hot off the press just today, the proposed schedule for JDK 25 is now there. So you can expect to see it in September 16th for the final, the final release. Ramp down phase 1 is when the feature set is frozen. So no matter, so whatever features are targeted for JDK 25, that's what it is. So, all right, Jakarta EE11. So I told you last month or the month before, the core profile was released in December. The web profile was just released earlier this month, and they're working on the remainder of the platform, and they're now targeting next month for that release. So that's good news. And for those of you who may not know, the reason for the delay was that they are upgrading the TCK, or the technology compatibility kit, to more modern technologies. So that's a lot of effort in that. But I think it's well worth the investment for future releases of Jakarta EE. So far, as per my count, 10 specifications for Jakarta EE12. Those spec leads have expressed interest in those updates. And then, as I mentioned before, we're part of the Future Directions group. There's also a Jakarta query spec that'll be new. So this will all be meshed together with Jakarta data, Jakarta NoSQL, and Jakarta persistence. All right, and these are the proposed specs right here at the moment. I think the last one I saw was for transactions, I think. So that wasn't updated for 11. All right. And then, of course, the random drawing application for that. So, all right, I'm done for now. Thank goodness. So I'd like to introduce Ken. All right. So Ken Rimple is a software engineer, 3 decades of experience, who serves as a senior developer relations advocate at Honeycomb. He currently guides customers in instrumenting full stack applications and front ends such as Angular and React with OpenTelemetry, and has worked on a wide range of languages and platforms, including Java and Spring. Ken loves mentoring and teaching, and has written courses and taught developers in Java, Spring, Maven, Angular, React, and other technologies. And on a personal note, for me, I've known Ken, I think it's damn near 20 years now. So Ken used to be at Chariot Solutions, and they had the emerging technologies for the enterprise. And I've been involved in some way, shape, or form for some time. And so we go back, but I didn't realize it was 20 years until I thought about it. But so it's great to have Ken here. I don't think I've seen you for a few years now, but yeah. So let's welcome Ken.
Okay. Let me just double check that everything's working here. Yeah. Go ahead. I will sit down. It's fine. We're good.
Yeah, sorry about that. Yeah, so don't get old, okay? So if you remember, Venkat Subramaniam, who has visited with us at least 3 times now, and maybe 4, but he runs the Arc of AI conference, which is brand new this year. And then he has Dev 2 Next, which is year number 2 or 3 later this year. So in the early part of this year, Venkat was doing these raffles. And of course, you remember me providing a URL. So Boris was one of the winners. This is for a free ticket. And there was Chris and somebody else, and I forget who won that. But Boris agreed to do a 5-minute or so update on, his experience at Arc of AI. Oh, I can't see. Oh, it's
down here.
Okay. Thank you, Diane. Yeah. Okay, perfect.
All right. Arc of AI, it was a great conference. There were a lot of sessions. There were very few sales pitches. I learned a lot. There were quite a few speakers that I knew from my experience of taking courses on O'Reilly. There was Venkat, of course. There was Neil Ford. There was Ken Cousin. There was Josh Long. I learned a few things about various frameworks that can be used to do AI using Java, such as Spring AI or LangChain4j. There was a significant amount of hands-on sessions, especially with Venkat, where he showed how to actually use IntelliJ to write the code quicker and faster and generate tests using AI. There were some architectural discussions also about how to architect Java-based AI applications using, normal principles of architecture where everything is trade-off and you have to balance between various utilities, such as scalability, reliability, availability, etc. That was a very interesting presentation on how to use Copilot and ChatGPT with AI. where you can configure your preferences using AI. So say you can suggest to AI that you want to prefer a functional style of programming, and it's going to generate the functional type of code for you. There were some discussions about how frameworks support RAG, where you can load your custom data into the AI model and have it parse it and vectorize it and give you the proper responses based on that. Josh Long had a fairly nice presentation on Spring framework for AI. So for anyone using Spring, I mean, that's probably a way to go. Although LangChain for J is older and maybe a little bit more feature rich. And of course, you need to have good prompt engineering skills to get the best out of AI. I mean, some as good as the prompt that you give it. What else? In my personal experience, I used AI for like converting things. Like I had some encryption example written in Ruby. I had to convert it to Java, for instance. I plugged it into ChatGPT and it converted it very quickly. It was fairly complex piece of code. And sometimes I can optimize the database queries using AI, which also very helpful. You can give it like a couple of tables and a query you want that sounds slow, and it give you a whole bunch of suggestions of how to rewrite it, or how to optimize it. So yeah, I mean, very good conference. Nice location in Austin, Texas. Many conferences. I've been to some before, maybe not a lot, but some. I mean, give you like try to sell you a particular product. Out here, I mean, it's been very technical, very. Thank you.
Totally agree with the whole AI prompt. It's only as good as you give it in request. I've been spending the last couple of weeks, and I have a lot of background in Spring and Java. I used to teach it, used to consult it at Chariot Solutions. Before that, at another company. And but it'd been a while, So I had decided to use Cursor to help me a little bit, which is another AI tool with an agent. And it got me somewhat on the road, but I felt like here's my cool. I felt that what I mostly did with Cursor for the first 4 days was curse at it, because I was yelling at it all the time because it wasn't listening to me, and it just because I don't know. As you're learning, you think that it's smart enough to understand things, and you forget to tell it enough. And so, boy, I had a lot of fun with it today, because I had the last part of the UI that was Tailwind CS based. CSS, and I realized that somehow I wasn't mounting the style sheet, because it didn't mount the style sheet because it really didn't finish. And then when I saw that, all of a sudden I had a good 2.5 hours, and it looks much nicer than it did this morning for the demo. So that's good. But I know what AI can be. It can be maddening and also really useful at the same time, or alternately, depending on what happens. All right. So let me get into my slides here. Just going to do this little screen thing to make life easier. So we switch around. Okay. So the talk is bugging production tree. Basically a primer for Java engineers, specifically around Spring for this particular talk. But we'll talk about Spring versus not Spring as well. You've seen me. Here I am. I never got around to putting the handles in, but I'll send that stuff along. So yeah, full stack engineer background we already talked about. And I joined Honeycomb in October of 2024. So I'm relatively new at Honeycomb. So what is observability? So observability is the ability to understand the state of a system by observing its outputs. If you've got useful outputs of a system, telemetry information, you can observe that and pay attention to it and make assumptions about what they mean. It's observability. In observability, we focus on three types of signals. Traces. I think everyone here is a Java developer knows what a stack trace is, right? A distributed stack trace can be really challenging in traditional tracing to get right. But OpenTelemetry's goal is to make that straightforward. So as you're using a cloud-based system with many different services, if you, what they call instrument all the services, you configure them with OpenTelemetry, you can get a completely distributed trace across your entire interaction and go through it and see exactly. So it's a directed acyclic graph of events. Logs, we all know what logs are, right? Structured logs are better than not structured logs, right? So if you're sending logs to an observability platform, you probably want to use JSON or something to ingest the logs. So the properties have names. You can look up the different chunks of it rather than always doing a text search of a huge heap of messages. But you can certainly ingest and take logs with observability. And you can hook them in from various APIs. I'm going to lose everybody now. Metrics. So in the past couple of years, a lot of people that are coming into observability platforms really want their existing stuff to work, the Prometheus stuff, right? For example, they're looking at metrics and they want to see, their graphs and their dashboards. They want to get that same kind of data from the observability platform. And so they've been asking for this. And the OpenTelemetry, thank you. The OpenTelemetry, which is the standard we're going to talk about here, they've been focusing on that. So they've added metrics to OpenTelemetry as a feature. And so you can ingest metrics as well. At Honeycomb, we kind of feel that metrics are kind of useful, but really they're pre-summarized, as we're going to look at. So the real power you get is by not using the summarized stuff and grouping them the way you want to group them when you're in the tools. The metrics are generally regular cent aggregates. So they're useful in a way, but not as useful as they could be. So how do we get to observability? And then we're going to break so people can eat too, because the pizza's hot. So we'll just do that real quick. But I'll do this first. So first of all, you start by instrumenting your code. You configure your agent, or you configure Spring to boot up with OpenTelemetry, for example. And what it's doing there is it's then going to start producing telemetry. It's producing information, traces, logs, and metrics. Right, so there's the telemetry, and we're using the OpenTelemetry API. Cloud Native Computing Foundation created the OpenTelemetry API. It's a merger of OpenTracing and another tool, which I can't remember of anymore. But basically, they created this thing called OpenTelemetry. It is part of this NCF. It's like the second largest project. The Cloud Native Computing Foundation, the second most popular one. You can imagine what the first one is. It's Linux. So there's a lot of attention. There's a lot of focus being paid to it. I went to KubeCon in November. Great conference. And it was in Salt Lake City. And all I can tell you is there was a wing of observability tools. So, we really helped kind of set the standard for commercial observability at Honeycomb. But there's a lot of people running right behind us and getting there. So it's interesting, like we've helped grow OpenTelemetry. It's really become like a community with a lot of different players. Still an open source API, donated, managed by a number of companies, including Honeycomb. We donate a lot of time to the OpenTelemetry project. You're going to put that telemetry into some sort of data store. And this is where all of the vendors put a lot of focus. How do we get this stuff into data stores that we can query it fast enough? That's the challenge, right? You're getting a stream of stuff sent to you all the time. How do you design something that can store and quickly retrieve it? And every one of the vendors has a different take on this. Honeycomb is one of those vendors. So we call ourselves an observability platform. There's a free version, 20 million events a month is what you can get for that. And there's like, Pro and then Enterprise. You don't have to use us. The API itself is a It's like JDBC. It's a common API that you're going to use, and you can go to whatever observability platform you want. Those are metrics, right? Yeah. So I think you can get micrometer metrics into Honeycomb. You should be able to. In fact, it's one of the when you auto instrument with Java. If you use a Java auto instrumentation, it looks for and sends micrometer stuff that's there. So the answer should be yes, but I have not personally done. And I know micrometer was one of the earlier like releases of technology in Java. They started pushing OpenTelemetry data out for the Java platform, and now OpenTelemetry has like the core platform. So I think it's just one of the instrumentation types that it detects, which you can turn on and off. All right. So with a tool like Honeycomb, with a free tool like Jaeger, that's another common OpenTelemetry tool. With a custom data source you build with something like ClickHouse, you can ingest this data and store it somewhere. And then the goal is to query it or to be notified when things change based on if your platform does that, like with triggers and things like that. Service level objectives. Those are some of the things we do. Bottom line is once you do that, then you've got observability. You have the ability to see what's going on because your code, but the outputs of the code are explaining what's. So let's talk about fidelity. Fidelity is what you do is how well you can understand it. Now, one of the challenges is you have to store it and cost money to store it, right? So every vendor has a different pricing scheme if they're not free. And if they are free, then you're dealing with storage prices yourself. So you have to think about the volume you're sending and what kind of things you're sending. So we'll talk about that right after the pizza. We'll talk about that. We'll talk about ways that you can kind of reduce the output you don't care about and only focus on the things you want to look for that are non-normal, right? You're looking for things that are not nominal situations. Something happened. I need to report it. And maybe some things do matter, like the business level, but how many customers want to be. People check. Let's see how. So that you can then look for those things. But if you take like a spring boot ball and you ingest every single item of a spring boot ball, you want to store it, turn on your trace, but you have trace level, bug level, a lot of data, and you're probably never going to look at it. 80% of it, you're never going to look. So maybe you don't ramp up your log. That's well, that's not a great idea. Hey, they gotta go somewhere and take storage. But maybe important to have some. Maybe you want to reward them, for example. And that might be really useful, but you want to see when things are really a problem in your logs. So there's some things to think about. All right. So let's take a quick break so you can eat pizza. We'll get to this. We'll do that first, and we'll. So you guys implement the OpenTelemetry. We don't implement the OpenTelemetry spec. We use the ingestion plan. So we take the data. Yeah, we take the data that comes in. Now, I should say, I'm going to talk about front end observability at the end of this for the last third, because that is not completely standard yet, because there are a lot of things that are under open discussion of what they're going to be. We have our own SDK on top of the base SDK. And we will send extra attributes in. Like, for example, for the browser, we know by looking what the browser does, we know like the height, width, browser, all the stuff, the version. We do that for you. And our goal is to get it so that it gets submitted, or we then adapt to whatever the standard will be once there is an SDK. We did this before. We did this before with, which one was it? It was the JavaScript SDK. We had our own early on when we were first getting started. And we ultimately switched to using this commercial. Oh, not commercial. We were using the open source official one because we didn't need it. And we were on the standards body. So we could, I was just on a meeting today where we were talking to Microsoft and other companies. And where they're headed with front end observability, which is like the big push now for us. One of the big pushes. OpenTelemetry 2.0. Mm-hmm. Right. So turn on and off different things and send their own telemetry or something like that. Right.
With animals and telemetry now.
Okay, I get you.
So that's the thing.
Okay, interesting.
It's yeah, it's an amazing. It's 6 7 months.
Yeah, there's a lot of stuff swirling. There's a lot of these changes that have been happening last year, especially when they've started adding like logs and then metrics to OpenTelemetry. They call it the 3 pillars, right? So you've heard this 3 pillars talk. We're all like, yeah, 3 pillars, because we said it so many times. We're tired of saying it.
Yeah.
But it's the problem with the concept of these 3 different things of go backward, of traces, logs, and metrics being separate, right? Is that you start thinking initially about, well, maybe we need different systems, right? Maybe one need log stash or, L or something. Logs are ingested really well by a tool like that.
Yes.
Right? And maybe traces will do with OpenTelemetry and like behavior or Honeycomb or something like that, great. And then for metrics, maybe one needs Prometheus, or they already have Prometheus, right? So the goal of OpenTelemetry as a standard is, why not use one tool? If you have your data in the right place where you can query it all together, and this is one of the things Honeycomb does, you can query it all together. You can bring the logs in and see logs and traces, for example. And say, at this point, I'll show you that. You'll see a Spring log entry in a trace and click on the little dot and you get the whole log right there.
Okay.
So, if you can get it in one place, you don't have 3 different systems to go through. And that's one of the goals of OpenTelemetry, is to define the standard in such a way that you could split it off into different things. You could still put things in Prometheus, for your metrics, and you could still put your logs in Kibana or whatever you want, or throw into an S3 bucket for later, right? You could just do that for now. But you could, in a tool like Honeycomb, you could store them all in one place and query them.
So you guys like competitors with one?
Yeah, our competitors with Splunk and Dynatrace and all these other companies. Yeah.
No, I mine.
Yeah. So in the logging space, we recently added the it's called HLA, Honeycomb Log Analysis. So we made it official that we directly support logging. And there's full stack searching. And if you send in JSON, we make the properties available to you. You can query it directly in our tool. That's like last year, I believe, timeframe that came out. So we now support it just like the same level as traces and metrics in terms of data. Oh yeah, I'm sure. Yeah, I know. Because did you see Martin Thwaites there? Probably the crazy Brit who was demoing things was one. Yes. Yeah, I was watching what was going on there. It was kind of fun to see all that stuff happening. So, all right, 3 really quick steps. It's done. Look, we're done. And there's the eye. We stared at that. I don't know why. All right, so let's talk about a trace. I mean, everyone knows what a trace is in software, but a trace in distributed software is a little bit, because you've got steps trace and you've got the service they came from. So let's talk about some of the things that make up a trace, right? The trace has, trace itself has an ID. The trace ID is generated when you create the trace. Some initial event kicks off a trace, so it generates a trace ID. That trace ID is sent along all the requests that go through the system. Now, I'm only showing you one flat server, but I can go on and show you briefly like in the over demos and have Kubernetes. And you'll see different, as I'm making a call from this thing to the front end, back end, the front end service, and then it goes off and spawns calls other things. You're propagating the trace using headers. So the requirement is with the trace, when this front end, this is the front end that's all agent get, so you can get on something on a browser. That thing comes from e-commerce React app, and Honeycomb's plans are building open source libraries to develop its source. It uses the browser API of OpenTelemetry JavaScript, and it sends frames. It sends the call to get API products in our Spring control. It sends it ahead. A header is called the W3C trace parent. So if you heard of the trace parent header, it's a standard in W3C and then the standards body. It's called trace parent, all one word. And it's basically a primary encoder. It's something encoded our basic before. It's got a trace ID. And then each of these things are called spans. Span of time doing something, right? So in your code, either automatically or through your code, you're creating a span or the system is creating a span. Automatically. And it's going to start off the span based on the trace that it got when it received the incoming call. Now, the rest of this is all inside of the string. I'm purely in this demo right here, this example right here, I'm showing you a sample that I wrote. Let me switch to another one. This is our standard. I didn't do this demo for the whole talk because I knew that we're doing Spring and Java here. And I think there might be one little tiny piece of this that's Java, and I don't know how old it is. But let me find it in here. I need to get the link to this. This is it. There we go. So what I'm in here is I'm in the Honeycomb query tool, and I'm just going to do that to bring up a trace. So what I want to do here is I want to find some traffic. All I did was I basically said, give me the last 2 hours of traffic on this demo tool, this demo application. And the demo application will come back if I just hit run query against this thing. Come back with a bunch of things, a bunch of span. What we're seeing for traces. Okay, so a span is part of a trace generally. There's also log spans. Those are like events that happen that are log events. But concept-wise, most of the time when you think about span, you think trace spans. That's what you're going to write your instrumentation to do. I can ask a tool like Honeycomb. I can say, what is the, well, first of all, let me group by, let's group by meta dot signal type. Meta.signal type is the type of message. Is it a log message? Is it a trace? Is it a metric? When I run that, they're all traces. Down there at the bottom, it says trace. So let me make that larger. A little bit larger. So we have, in the last 2 hours, 1,342 trace spans that went in. Now, what's happening behind the scenes here is we have a data load generator that's generating load to this service. If I go and find a trace, colors indicate different spans and their rough duration. So most of these aren't that interesting to me. That one is, because that's the one I just stumbled on by opening the app up, because I actually physically had to go, the browser had to go to the front end, which is a Next.js front end, React, with server-side React. What's that? Yeah. Oh, yeah, you can bring it up by duration, you can sort by duration, you can group by, we can do all sorts of stuff. But yes, we absolutely can. For example, if we said, I want to see a heat map of duration in milliseconds. I want to see at each slice of time, how many things took how long. So I'll show you. It's better to see it than to do anything else. So let me run it. There we go. It's a little bit better. So with a heat map, let me change my let me change how much I group it by. Go in here and say that my granularity is 1 minute. Makes it a little more coarse to see. So every minute it's taking in this graph, it's breaking up all the calls that it has in that minute time frame. And whatever one is a particular duration for that slice of time, it's going to put it in this bucket. Now, the more that you have, the darker the bucket is. And there's a little thing here. It says on the left, on the right, it says there are 20 spans or more if it's dark. If it's light, there's 1. So now, armed with that information, you could say, well, there's a lot of stuff that happens in around half a second. But there's also stuff that happens in 2 seconds and 2.5 seconds. Slower stuff. So what we're seeing is a visualization that's, you can kind of think like SQL, but with smarter than anything. You can say, I want to see how these calls are all made against a particular attribute, particular piece of information. I want to see how long they took. Now, the telemetry, we're just looking at that. We're looking at trace spans. Every one of those is a span for a trace. If I hover over it in Honeycomb, it tells me how many are a particular type. But the other thing we've done and other companies are starting to do is this concept of bubble up. So you can say, I want to see what is different about these particular spans. Why are they different than other spans? So you put a little box around them and you tell it to detect anomalies. We used to call this bubble up, but now we're kind of figuring out. Everyone calls it bubble up. Detect anomalies is better. So you gave it a little bit different name. And now what it does is it says, I'm going to take the time frame we have on the screen here, 2 hours. I highlighted 1.79 thousand milliseconds or 1.79 seconds to 2.4 seconds. And those will now be in, and the rest of the spans that I have in that time frame are in blue. So we can start seeing what is different about these particular spans up the top, right? Yeah, they're outliers, exactly. So, okay, something's going on. Some of this stuff doesn't make a whole lot of sense. Okay, so apparently calls to cart without any query params are the bulk of these. I don't know what that means to me yet. But the whole point of this, as I'm going to talk about here, is that once we see this, let me just jump ahead a little bit. This is one of our CTOs, Liz Fong-Jones. Once we see this, we can start what we call the core analysis loop. So you're like, okay, I'm looking at the data. I have a question. So you ask a question of it like you do in a query tool. It is a query tool. You make an assumption. You validate your assumption by visualizing the telemetry. And you find anomalies, like with a bubble up or like by digging deeper or grouping by something. And we're not the only tool that does this, but we like how. And you can then search, filter, group across what we call common dimensions. Every attribute that you put in there is a dimension you can query. For a browser, this is things like the browser version, the platform it's on, whether it's on mobile or not, what the resolution is, how big the window is it on mobile? And so that's that kind of thing. For any of those, there's always a duration in milliseconds for the particular thing we're looking at. All right, that has to be there because it records from the time you start the span until the time you end the span. That's the duration. That just comes with it. And then did we solve the problems? Did we know what this is? Oh, we did because we're done. But we can always go back through, refine the question. There's a book that Liz Fong-Jones wrote, Understanding OpenTelemetry, or Understanding Observability, that's what it's called. They go through this whole thing. But I put her in there because the names are kind of like technical, but all we're doing is we're just querying and adjusting we're doing a hypothesis, we're testing the query, we're visualizing to make sure we know where things are. In many cases, we find things through observability before the customer even knows they're a problem, because we're paying attention to them, because we can see them and visualize them. And that's what you want to do. If you implement observability, you want to observe things that you can handle. So for example, disk space is starting to fill up on a particular server. So there's an example of a metric that would be useful, because this metric is disk space. I need to know when it starts to fill up. Okay, that probably matters. I can also send it as a span of a trace too, if I can get it. And then I don't have to have those really heavy metrics with tons and tons of summarization. I can just query spans. Yes. Yes. So your question is a good one. Can you get it from your, the underlying cloud providers and such? OpenTelemetry has turned off by default detectors for like AWS, for example, for Google Cloud, and I think a couple others. As instrumentation, you turn on when you want to do this kind of thing. So you can see, for example, with lambdas, we use a ton of lambdas, right? We have a lot of lambdas to run our certain types of queries. And so we have that information. And because we're running on Kubernetes, there's a Helm chart for Kubernetes. It will send that information through. So yeah, absolutely. You want to get that information in there. Whether you put it in a metric or whether you put it in like a span, depends on your case, what you want to do. But yeah, absolutely. Okay. So let me go back to this demo. I think it'll be useful for kind of discussing this a little bit before we dive into some code. So right here, one of the things you'll run into a lot, I ran into a lot when I first started using Honeycomb, still do. You'll make an assumption and you're totally wrong. The good news is you don't have to write like a query in something like Prometheus PromQL and deploy it to get the query to run. You can just ask questions. That's why SQL's so great, right? Ask it questions. Worst you can do is be wrong. Try again. So, all right. But that was a good question about supporting cloud providers, because you have to. Everything's cloud-based these days. So, yeah, apparently I don't know what to do. So, oh, right. We're going to go back into this. All right. So one thing you could do is you can do this, bubble up and anomalies thing. You can come along and add another graph. So maybe I want to do a P75 of, I don't know. Let's see. Let's do HTTP response content. That's the dumb one to do. Let's do average response to content length. All of it. So those attributes are attributes that can be on any signal type. Right now, I'm grouping by signal type, but I'm going to turn that off because I only have traces in this data set. So let me wipe out that. But if that's not on there, you can look across metrics and logs and traces. You can filter down to what you're searching for and only include the ones you. So here we go. So average of HTTP response content length now becomes just another graph to look at. But content length of what response? So this is where, when you use observability, the more attributes you have, it's your superpower, because you can take those attributes and query all day long on them, finding things that are interesting. All right, I want to compare the content length to what HTTP method and call they're doing, right? So I can come up here and I can group. Grouping is basically show the values. I want to see the values in the bottom below the graphs, grouped up like a group by. So, all right, I want to do http.url, http.method, and http.status. Run. All right, so we're doing these visualizations and we're going to group them. You're going to see different like color coding based on these three pieces. So you can kind of move over these things. Now, this is not easy to see it this way because it's just like a quick pop-up. You really want to go down to overview. And now we get to really useful stuff. So let's sort by our status code. Nothing's failing. That's not so much fun, is it? You want to see something that fails. Here's one. So National Park Foundation Exploroscope. Aren't they? This is showing there's a lot of them. Content link is 21.6K, I guess that's what it is. Yeah. So it's giving you things you can look at and you can start to dice and slice with. And the way this thing works is as you kind of move your way through, what this really means is there's a lot of these calls. And the height is how long you took. Or maybe it's how many of them, I forget actually. Let's do that quickly visually. Yeah, I think it's the number of them. Because look, they're all the same height. So that's the number of them. The higher the bar, the more spans there were. So there were a lot of spans with the red flashlight. Always wanted one. And then everyone wants the Eclipse Smart Travel Refractor Telescope. Am I right? Telescope demos, right? Very specific store. Okay. Now let's dig into some of the data. Let's take a look at what these spans look. Oh, forgot. I was going to show you a trace. So let's go into a trace here. So let's look at traces again. And why don't I see? Let me pull this back. There we go. I want to get back to this. Now, again, I mentioned before that the novel traces, the interesting traces, rather, the ones that go through a lot of stuff. Right? So there's a really busy trace. I can go and click on that trace and bring it up. And now here, and this can happen too. I know why that's happening in this demo set. Probably because we're sampling the data and we didn't sample it right. So we're working on that on this demo. But yeah, because the very second span is going to our backend for front end, and that span's missing. So there's something misconfigured with the particular app. But if I follow this through, let me just kind of show you. We start by a get on front end web. Something happens. Then we go to the session gateway to get we get the cart information. What do we have on our cart? That leads us to call get API cart in the backend for front end. In case anyone here knows Next.js, this is a Next.js server-side component, server-side function. They call that our backend for front end. So it does the calls and the other things for us in that demo. Then it's executing a route to go to API cart. Now, remember how I told you trace parent was the way we propagate traces in OpenTelemetry? True. There's also something called B3 tracing that came from Zipkin. And it's another competing standard that when Open Tracing and OpenTelemetry merged, we support both ways of propagating. So this demo has propagated traces in two different ways, using B3 tracing, which is one way to do it. B3 is a protocol. And gRPC is the actual protocol. B3 is the header. And then using the standard OpenTelemetry stuff, which is something called OTLP, which is another one. And that uses trace parent. So you may see like different, terms in here, but if you see gRPC, that's kind of the old way to do tracing. More of a binary format. The other way is protocol buffers, and that's what the OTLP is. So we'll talk about that a little bit more when we dig into instrumentation. Yeah, you basically add the dependencies for OpenTelemetry, and you would configure the app to run with OpenTelemetry. So a Java agent is one way to do it. Another way to do it is Spring has a Spring Boot starter that does it. It loads it in process, so you don't have to burn a Java agent because you only have one, right? So you want to debug, for example, the Java agent is going to be somewhat difficult, I think. So, for example, for me, I have it on debugging for Spring, and I use the Spring Boot starter. So that way I can run the Java agent for debugging while I'm developing and still send traces out. So basically, you have to configure your VM, your application under the VM to run the tracing APIs from OpenTelemetry. So this is Honeycomb. So the Honeycomb front end is what I'm using here. So this particular one's commercial. It's ours. And there's a 20 million, if you want to play with it to learn OpenTelemetry, there's a 20 million events a month free version. If you're looking for an open source tool to do it, then you can use something called Jaeger, Jaeger. That's a pretty common one. There's another one, Aspire, that .NET does, which is an in-memory one that you can visualize things with. And then like Grafana has one, and Dynatrace and other companies as well. So there's like a number of commercial ones, a number of open source ones. And if you go to the OpenTelemetry website, you can see them all. But they're all using this API, which is the great part. So you don't have to use Honeycomb for this. But I'm using Honeycomb to show you how you can query this stuff. All right, so we do a post. So now, cart service, which is another service in this call stack. So we started with the front-end web, then went to API gateway. It ran the route. Then it's doing a cart service get cart, which ultimately turns into a post. And that post, just because we want to make things really confusing, we added a cache. So we're doing an hget for a cache. We also have flag D for our versions of things and turning things on and off in the demo. So we just made this as complicated as we could for a trace to show that you can do it. And it's kind of typical for larger applications. You have a lot of different things that the app goes through. Ultimately, though, we have a query. Select from products and cart service. So the cart service in this application, this demo application we have, has this query in it. And you'll notice the SQL is there. On the right here, I can explore the different fields so I can look at the SQL or the query. What is it called? There. It's called name. That's another thing we have to talk about. Spans have names. And the names of the thing that you see here. If you make a really long name that doesn't get really unique until the end, you're going to have a hard time. Because you want to see the interesting stuff up front. So like the first mistake I generally make is I put the package name in the front of the class. Don't do that. Because you won't find it. It'll be hard to see. You can query for it and say where it starts with some package name. You can also say where it has that package name too. But visually, it's kind of hard because you only have so much screen real estate to see the full usefulness of the span name. If the span name is not that unique towards the it turns out with the automatic instrumentation, they know how to detect instrumentation for things like Postgres databases, JDBC, JPA, things like that. And they'll actually emit the query. They won't emit the parameters by default. They won't show the values because, there is always concern about personal identifiable information. You don't want to just make the API automatically give you all the data because then someone could use that in a way that's probably not legal in a lot of companies. You don't want to put bank account information in traces, right? So if it's important to you for personal identifiable information not to show up, there are a variety of ways to make sure you scrub that data so it doesn't show up. But by default, we're not going to do crazy things like show all the parameter values. You have to instrument that yourself. And that's one of the things I'll show you how. Now, because we're making all these calls to all these different services, sorry, I have this in the way here. And I'm in the way. Get out of here. We also can take a look at a service map. And although a lot of these tools in observability will do this, because we're getting telemetry in from different services. Think of your app as a service. So as you're building a microservice, you'll probably have a service name for that microservice, which means that you'll store that in OpenTelemetry as a service name, and generally the data is stored with a service. So we have these things called data sets that directly correspond to the service name. As we are starting to look at the telemetry, we can always query and say, what's been running? What do we have? It's a jumble, isn't it? Front-end web made a call to API gateway. An API gateway called cart service. Get over here. Right. On average, the worst 5%, like T95 would be like, what are the worst 5% of users feeling? right? It's the latency. 95% of users have a better experience of these four souls with this latency, right? So it's saying 22.6 milliseconds. That clearly isn't a problem. The larger the circle, the more calls we have, I believe. It definitely isn't the latency, because the latency isn't that much different. But I think it's the number of calls. And we can filter this. So for example, I can say, I want to see services. I only want to see, let's say, API gateway and product catalog. So all those systems that we're talking about, all the ones that are commercial generally, will give you the ability to look at services. And this thing is queryable over time. Notice that's the last 24 hours. What happened in the last 10 minutes? What did I just do? Or what did the service just do? So kind of interesting. You can do that once you have data with that kind of information. But let's take a look at some spans. Let's get a feel for what the spans have in them. Okay, so I'll go back to query, and I'll just run a query. By default, it just does a count of all the spans. And now we're starting to look at the data. So I'm going to go here into Explore Data and click on one of these things. Now, span this out. Good. Each of these entries here are spans. Let me put the service name in here so we can take a look at it. So I can add whatever I want to this in this tool. Service.name. So now I know when I'm looking what service we're looking here. And by the way, we're all going to be front-end web. Front-end web is the data set I'm querying right now. So if I go to the top, data set is front-end web. Oops, it's the front end. So because it is, our spans are going to be instrumented in such a way that we're going to have front-end type of information in a span. So I'm going to go over here and just open one of these up, and we're going to zoom down and zoom in. Take a good look at these. So this is an example of the types of things you can put in OpenTelemetry. Put things that are useful, that have a high amount of cardinality in when you can. So meaning that there's a lot of different variants in the values, so it's easy to query against them. Because they might vary a lot. And maybe that one variant matters to you. So the high cardinality, high number of differences data is really useful for comparing. But also you may want to find out how many your desktop. So low cardinality values are also used for desktop or mobile, right? Still good. You can combine that with other ones to really figure out what you're looking for. So look at this. We've got browser language, mobile, name, touchscreen enabled, user agent version. The width, where it is the duration, millisecond, of course, because that comes with it. Right. So this is just the kinds of things. Now look at this. Because we're running on Kubernetes, because we've instrumented this app to run on Kubernetes, we've turned on the Kubernetes information, and it's telling you deployment name, namespace name, node name, what pod, IP address, and so on. Another interesting thing is to find out where the telemetry is coming from. So library.name, sorry, I should be grouping by that. Doesn't want to see it. Show me the values grouping. We'll show you where the telemetry is coming from. And let me just minimize this. Oh, I need to show it in overview, sorry. So I've got telemetry turned on for all of my fetch calls. That says OpenTelemetry fetch. Let me make that larger. Instrumentation fetch. So this is the built-in fetch instrumentation, or easily available fetch instrumentation. It's part of the OpenTelemetry browser library. And that's what, when you make a fetch call, that's what then propagates the trace to the other side of the call. And it will record the get, like the HTTP method and response and all that stuff. Then there's document load. This is, okay, I grabbed the page. Now I'm grabbing the JavaScript. How long did it take to get it? How long did it take to render it? So when you are using a single page application, like React or Angular, when you boot that first page up, you're going to get document load and document fetch. You're going to get these events, these named spans that say it took this long to do this stuff. And you can start finding out things like, okay, that JavaScript is huge. It's taking a long time and it's big. So we're going to make that small. Okay. Now, so let me make sure my app is running here. It is. Oh, I'm not looking at that message right now. It'll make me sad, whatever it is. All right. All right. This is a very cheesy, simple application. And I'll give you the source to it so you can look at it later. It's a React app. Yes, it's a React app. It was Angular until I yelled at Angular enough that I changed to React. I had a bad day with Angular. So this is just a really simple shopping thing. Great. And I just used Tailwind CSS with my friend Cursor to get that done. And as I'm doing these calls to add things to cart and whatever, that one was meant to fail. I designed that particular one to fail. So I have an interesting trace. These are all, and yeah, that's a broken image. I never fixed it. These are all making calls to a Spring Boot application from React. So it doesn't necessarily show you by default how long it takes to render anything, but we have Core Web Vitals installed as well. So Google's Core Web Vitals library is part of the instrumentation that we add in. So Honeycomb has a library that wraps the OpenTelemetry browser library, the JavaScript library. And in our library, we automatically load Core Web Vitals. So it'll tell you, oh, it took this long to load the page. It took this long to paint. The layout shifted. So we add those as spans, which I'll show you. So let's hold off on that for the front end part of the talk, but I will show you directly mine. But the answer is, yeah, we can provide that. And you can also do this you can use the Honeycomb library for any open source destination you want to send this to, because it's just spans and traces. So if I go to cart now and I check it out and I do this fake purchasing, great, something happened. Things happened. I want lots of things to happen. So let me make a lot of things happen here. There we go. Let some things happen. All right. So now I have code running, kicked off, instrumented, doing. And as I let this thing kind of move along, last 10 minutes there. So you'll notice it said last 10 minutes, 30 days ago. Because apparently decided that I don't know when I want to get it. But if you've done a query recently and you bookmark that query, we basically hydrate the query data into something we can always send it around later. Even if it's a month later, if I send a trace to you, it'll bring back that exact piece of data. We're just like storing the report in our services. But all right. So here's the last 10 minutes. What were we doing? And I have some things that I'm searching on here. I was trying to get rid of all the document load stuff because there's a lot of spans that show up. So it would just flood you with our test because I'm constantly creating a page, click, 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 log out, create a page. So you would just see a ton of document loads. Like this, take it all. So I said, you know what? I'm just going to skip that. I'm going to make sure the signal is traced. Library name is not OpenTelemetry instrumentation document load. Instrumentation document load is the winnable load. And also, in this example, I didn't want to see Core Web Vitals either because I just want to see actual churn of application calls to services on the back end. So I'm just kind of like, let me see the cool stuff, get the other stuff out of the way because I'm maybe not looking for like page load times. I'm looking for application interaction times from the API in this example. I'm going to group it by service name and then the name of the span. And that's why this is such a colorful graph because it has a lot of information in it. So one thing I didn't think this include was my load generator. my load generator is busy sending a lot of spans and it's running OpenTelemetry, so I can see how long it takes to do its stuff. And my load test, I basically made one span from the beginning of the load test to the end of the load test. That's why it's like 40 seconds long. So I need to get rid of those two. So what I can do is I can filter that out. Let's see, service name, playwright, load gen. So service.name not equal to playwright load gen. Gotta get that out. There we go. That's a little bit better. That's a little more typical. No, it looks a lot like SQL, doesn't it? But no, I think they model it after SQL. And the reason it's not SQL is because you can do those things like heat maps and, different types of charts and things like that. But it is very similar, concept-wise, it's similar to SQL. We're not using a relational database on the back end. We've talked about this a lot. If you look at our engineering papers, we have a columnar data store that we put together for it. Running in AWS, we have a very tailored, high-speed columnar data store that we care and feed the way we do. If you did with ClickHouse, you're going to be doing something similar. It's like a column-based data store. If you ingest it into ClickHouse, you would have to manage that and figure that out. Use Jaeger, it's going to do its same ingest and it's going to store it somewhere too. So,
Column data stores that.
Yeah, it's a NoSQL of some sort. Yeah. Like a Cassandra or something like that, I guess. Not exactly sure the internals of it, although I've been in a couple of meetings. I'm like, I'm not ready for this. Smarter engineers than me. So if I grab any of these traces, we're going to see stuff going on. And that's where you see similar to what we had before in my earlier slides. Let me move this out of the way. Come on here. There. This one's a post. So I'm adding a card, I believe. Yeah. I'm adding to the quantity input. So my post on a React app hits my front end, hits my controller on my Spring app, which then hits the update item quality. Now, automatic instrumentation, built-in instrumentation. On the front end, I have the built-in fetch instrument. Post API, that thing, built-in instrumentation. If you instrument a Spring app controller, it's going to run standard. So I know what hit it. That one I did. Because it looks weird. It looks like something that I just want to make sure it's my method. It's not a long update on quantity. I am creating. Well, actually, it's not true. I think it's a transaction. Because if you look at the library, I open OpenTelemetry Spring, that's actually auto-sortation. But I tell you, I actually will do inside of code here, I actually create span. So I add things to span. So I actually say, span, I don't know, put them in me. But yeah, this actually is the method name. So I was wrong at first. I had to look over here and it just told me what. Then we have data source. Hey, using data source. How long did it take the data source to have to release information? So my data source is still important. There's a select. There's a couple queries involved in here. There's an insert, there's a delete, there's an insert, there's a pretty stuff. Just a down. Definitely not optimized. And I'm using JPA and Hibernate, which means it's definitely not optimized. If you just play with Hibernate, you generate a lot of C. I should have done JDBC template and been smart, but I didn't. And you're the beneficiaries, you see a decent trace. All right. Okay. So let's look at some of the code and like how we do this. Back to my presentation briefly and cover some of those bases. Where is my slides? Where are my slides? Yeah, I guess they're here. Oh, time moved. All right, let's look at this. If you use the Java agent for OpenTelemetry, so you go to the OpenTelemetry website off of CNCF, the Cloud Native Foundation, the Beauty Foundation, there is an automation that automatically it's done when you use the Java agent for OpenTelemetry. So if you don't have the source code for your job, if you don't own it, but you want to get automatic instrumentation to run so you know something about what's going on, you can take a regular app and you can add the Java agent and you can send it some environment variables or flags to turn on OpenTelemetry. And it needs at least a couple things. OTel OpenTelemetry exporter, because this is an exporter, exports OpenTelemetry. OTLP, OpenTelemetry Line Protocol. That's the protocol. What is my endpoint I'm sending to? I'm using Honeycomb, so we ingest OpenTelemetry, OTLP protocol format on API Honeycomb box. It's an API. So anyway, so we have these endpoints that ingest or balance. It's proceeding. The protocol we're using is protocol buffer. If we're doing it this way, now if you're using the Zipkin V3 tracing, or gRPC, you'll configure those different. But I'm using the OpenTelemetry line. Here's how we get our little license set. So we do have to give you a Honeycomb API for every one of your environments, which is the collection of services, and the whole thing is set up. For every collection of those, you can define an API key for each user or however you want to do it. And this is the key for setting in what's called ingest. The only thing to do is get data into Honeycomb. It can't create new users and into it. So you'll create a minor big deal of all. If you're using Jaeger or whatever, you point it there. Our service name, get standard name. What's the service name called? That's the name we're going to use to create our data set, and that'll be service.name in our. Then you run Java, pass in Java agent, OpenTelemetry Java agent, it's the name or whatever. And then you run your app. That's basically the code I stole from the code. So I'm just doing a Maven build, and ultimately I'm running that when I'm playing around with it in this mode. So again, environment variables and or flags that you pass with -d and things like that. Configure the agent has a ton of libraries available to it. So I hope I bookmarked this, and if not, I'll Google it. Java libraries and frameworks, that's the one. Okay. This is not Honeycomb, this is OpenTelemetry. What does OpenTelemetry support right out of the box? What is it instrument right out of the box? You name it, it's in here. Most of the Apache projects are in here. HTTP client, got it? Great. It's instrumented. My faces, wow. JSF in a trace. Good. I mean, there's code out there. AWS Lambda. If you've turned on AWS support, the flag, environment variable, whatever, you then will get Lambda telemetry, right? When was it activated? Was it passivated? That kind of stuff. How long did each call take? The whole SDK is a whole bunch of things in here. Messaging, database client spans and metrics, HTTP client spans, and all that kind of stuff. So you can just go through this. You can spend a lot of time. Spring's in here. Grails is in here. My buddy Grails from years ago. I loved Grails. So yeah. So OpenTelemetry, they spent a lot of time configuring so that it looks for all these features. Now, if you use the Java agent, it doesn't know what framework you're running on. So it's going to give you the kitchen sink. It really is. It's going to be like, oh, you use that library. I'm giving you a span for that. And you might have a ton of spans. Spans equals money in our world. So you may not want to do that. And in Jaeger or other tools, you have to store it. So do you want all that storage? So you may want to turn these off. And you can just turn them on and off by setting in a particular environment variable with some settings that say, I don't want this. Open source, yes. And we use it in the other companies. Yeah. It is. but it's no TLD header. So we will send headers to the service that's ingesting, and you'll use that for other vendors as well to set their settings through headers. So that's why it's a standard name for the library to send custom headers in. Yeah, that's why. Oh yeah, for the export. So it depends on how you're charged for Lambda traffic. We're in AWS. I don't know the exact answer to that, but that's a reasonable question to ask. Like, are you going to pay for? Yeah, for sure, for sure. And you could certainly turn it on a load, and then you could do like analysis of your network calls and things. We have information on ours, look at the data sets. You can see what the ingest amount is, things like that, traffic. But that's a reasonable one to ask. So I'm going to throw that in there. Because, with AWS, it's like how much it costs to get data out, right? Is one of the things. If you're sending traffic out, that's going to cost money, if I remember correctly. So it's going to be very dependent on your cloud framework and what you're sending and where. I'm sorry? What is that? I'm sorry. Oh, how do you spell it? Okay. Okay. Yeah, I don't know the answer to that off the top of my head, but uh-oh. Does it have another name? Oracle UCP. Yeah. Okay. Source is unclear. Shake the 8-ball. Try again later, right? I don't know. If I did, I'd tell you. But yeah, cost on AWS. I can ask a question and get that back to the group. Like how they figure that out. Because we use it, so we would know. Quick question to my engineering team, they could give you an idea. So if it does all this stuff automatically, why do you need the manual stuff? And I mentioned it earlier, because you want the novel things that matter for your business tracking to be things you can query about. So that's why. You can put things on existing spans if you want to. So if you're in a particular call that has a span that starts like a controller, anywhere, because we're in Java, right? Thread locals, right? In Spring, when you execute a call to a Spring controller in a particular virtual machine running Spring, all the things it goes through, it uses the thread local to keep track of the call stack and things like that, and things like transactions, right? If you start a span up here, the controller, you can get the current span and add attributes to it anywhere along the call stack, and they'll show up in that span. Or you could create a child span, up to you, if you want a specific span for your piece of information. But we don't charge for additional attributes the way we do it. And there are some companies that will charge a lot for additional attributes called additional metrics. We charge per message. We charge per span. But you can have a couple thousand, 2,000, I think is the general limit you end up with. Different attributes in a span. That's a lot, but that means we have a lot of rich data. So that's how we do it. Every business is a little different, but the goal is to get as much useful information in the span, enrich the span with stuff that you want to. Now, I'll just go to the code because I ran out of steam. I was doing slides and coding at the same time. My head was starting to melt off. So let me go to idea. My buddy idea here. What was the other ones? And I'll make the font larger. Please wait. All right, that's good. Yeah. Big. Is that okay? Okay, good. All right. So I've got a REST controller. I want that to show up. Excuse me. What are you doing here? It's a REST controller. mounted API cart, and I've got like it's all. So I've got get mapping to pull the cart in, and post mapping to modify to create the cart, I should say. And then I've got another one for updating the quantity of the items. Yeah, code. So let's look at this one here, update item quantity. This is the one I spent some time instrumenting yesterday. So there's an annotation. OpenTelemetry is annotation called with span. This annotation marks the execution of this method of construction in a span. So I'm creating a span when I hit the control. Once I do that, because it's an annotation and it's a rounded byte, right, with AOP, it's going to create the span, and it's going to end the span either happily or with an error in it, an exception, right? So that with span is a lot of carrying of things for us. MDC. I don't know the answer. I put that in there. Okay. I'll put a question. I'll find out. So, create a span. I would think it should be able to, but I don't want to say for sure without knowing. I'll find out. We look at that page later and see too, because that's the automatic stuff. But you'll also find there's a bunch of contributed libraries out there for OpenTelemetry that you'll find all sorts of code that teams have contributed. So it's possible that it isn't in the built-in ones. It's probably something that you could do. Or you can write a small wrapper around an existing library that does it, perhaps. Not sure if that makes any sense. All right. So we have our span. And to get the span in the code, we call span.current, static method on the span class. And that gives us our current span. And we just set attributes. That's all. Send a number, send, string, some sort of representation you can see and understand in query. Now, update quantity in cart here is in cart service. So there's my Spring Bean. I also asked for the current span. I didn't do a with span because I know that this will only be called from the controller, and I want to hop on that and add my information to the current span. So I don't actually add another span and cost myself. And also, I can query it on the same span. So it's like the same piece of information. This call to the controller resulted in, what am I doing here? Nothing useful. Down here somewhere. I make it blow up too. How much is what? It's very small. It depends on what you put in it though. So if you're going to do things like, let's say you're like using an LLM and you're like sending the inputs and the output tokens from the LLM into, it's going to be a lot, right? So they try to optimize this for speed. So the one thing is you don't want to turn on every piece of instrumentation. That's number one, right? You probably don't want to turn on log instrumentation because that's a lot of load. Although it'll be sent in batches. They do batch them up too. And you can control the batch size, that kind of thing. But generally, unless you're doing 2,000 spans all at once, or 2,000 attributes in a span all at once, it should be relatively low overhead. It's not like turning on a tracing tool in an application server. Like when you turn those on, it slows the app down. This generally doesn't slow apps down. That's a vague hand-wavy answer, by the way, because I'm not 100% sure of the amount of overhead, but we have people using it all the time in production. The term is test in production. It's relative, right? It's relative to how much you're instrumenting and what you're sending in the instrumentation. You're absolutely right. So if you're just saying, oh, these are the methods that I'm calling, and here are some of the key pieces of information, it should be very quick. If you're logging the entire response and putting it in, it might take a little while. Because now you're doing double duty of sending the entire response up to Honeycomb asynchronously, right, through an agent or through Spring's internal configuration of OpenTelemetry, the way they do it in the library, one or the other. And you're doing that in the same VM that you're doing your business work from. So you don't want to overdo it. Yeah. No, I do too. Yeah. So for example, things like, okay, I'm updating. So what would be the quantity for the item? Right. And then did I remove the item from the cart? And what's the new quantity? Right. So real basic things. Once you get the thing wired up and you start adding spans, it's relatively straightforward to get information in. Especially on the Java platform. It's relatively simple to either create a new span or grab a span and put it. And that's why we have all this information in our trace, which if I go back here, where is my front end? I need to close some windows. Oh, I didn't show that yet. Right. So you could do that with Spring profiles if you want to. Right. So if you're using the Spring one, you can set your application YML. In fact, let's look at that. So when you're using Spring to configure it, there is a Spring version. It's called the Spring Starter. They have everything Spring Boot Starter. Right? So started for everything. But there is one for OpenTelemetry. Yeah. So for OpenTelemetry, there's an hotel part. So if you install the starter, you can now configure it. I'm using the W3C trace context, trace parent. That's a trace context. OpenTelemetry. Yeah. Sure. Which makes it a little more confusing. OpenTelemetry. Naming's hard, right? So we can do all sorts of things. You can give service, what is the service name in here? You can do that with different profiles. So like you can turn on dev profile versus a test versus production, or not turn it on during unit tests. Probably a good idea. And then, for example, there's controller telemetry, which I've turned on. By default, they don't turn it on because they figure it's going to hammer you with tons and tons of output. But you can turn it on or off here. You probably get more fine grained than that. And then I have another one commenting out in here. For example, maybe you want to send your Honeycomb key in through that. Maybe you have other pieces of information. You can turn on or off different features like, I don't want to send logback messages or SLF for J. Right? Turn them on. So for all these different types of instrumentation, you can configure them in here if you use the Spring Boot Starter. Or you can do environment variables or flags to turn them off otherwise. And it's all in the documentation for OpenTelemetry. All right. Any questions while we're going through this? They're great questions so far, too. Wrong thing. Funny, I was telling the AI tool to look at our standards by doing a screenshot of our standard color palette. And I was telling Cursor, do a palette for me based on our standard color scheme. And it did it. It did a really good job. I was very surprised just from a screenshot. Okay, I need to make slides back. Got so in my head, I forgot where I was. We'll just zip on down. Oh, one other thing. And I just learned this yesterday about this because I wasn't sure. I noticed that the amount of tracing you get by default out of the box when you use the Spring Boot Starter, they're trying to be nice to you. So they don't turn on everything by default. They don't turn the whole faucet on. They figure you're running on Spring. So we're not going to enable every single possible instrumentation. So you get a smaller amount of instrumentation. And it's in the documentation. I found the actual chunk that says by default, a lot of things are turned off. You can then turn them on. So if you use the OpenTelemetry starter, it's batter up. All sorts of stuff's going to come out, and you're going to have to slowly turn things off. If you use the Spring one, it says, okay, services and beans and transactions and things like that. Won't do every single Spring bean because that would be crazy, but it will do things like transactional boundaries and queries, right? Controller if you turn it on, that kind of thing. Mm-hmm.
simulate conflict. I see contradiction in my diagram of system.
If you have the OpenTelemetry jar in your dependencies, it will not turn on OpenTelemetry tracing unless you put those environment variables in, right?
Yeah.
And right now, the thing is, if you write the code, this is an important thing about OpenTelemetry. If you write the code to send spans and you haven't turned on OpenTelemetry, they're just no ops. They don't do anything. So the goal is for OpenTelemetry not to damage your code, right? Even if it fails for some reason, it'll throw exceptions in the log to let you know that something went wrong, but it won't stop your code from running. So if you do your own instrumentation, if you hand build your span, only what you put into it will go in, with the exception they also adds the timestamp, the duration, right? And it knows like, oh, this span is based on a parent span of this trace. That stuff gets added. Okay. And you have that.
If the queries don't put it in the log, they don't get visible. You can add it in this.
You could, yeah. So for example, for queries, because you don't want to put it in by default, you don't want to put parameters in. But when you do, you just go ahead and join the span, like, span.current, and you set the attributes based on the parameters coming into the service before you call the backend, or in the backend API if it's like JDBC template. So whatever you want to do there. Yeah. But it won't do it automatically. It will just show the question marks for all the positions. Yeah. All right. We went through this in code and we did that. And what I'll do is I'll share this project with you. So I'll send this to Michael and he can distribute it out. I have a few minor things I would like to tweak. So you should get it by the end of the week. But you'll have all the source code to be able to run a React and Spring Boot project and play around with it all you want. You could change where it goes. If you don't want to use Honeycomb, you could point it to Jaeger, and send it to that thing. And we'll talk about this in a second because I want to talk about the front end. And because I'm talking about the front end, I get to talk about something called telemetry collector. I did this through AI when I was in Denver. We were prepping for a talk on front end observability. And the front end observability is solving the problem of I threw it over the fence of the front end and they broke it. Or we're calling the back end, and is the back end broken? We don't know. They might have their real user monitor RUM tools in the front end that says it blew up over here, but they don't have the rest of it. They just have that exception from the client side. Or the server blows up and they say, well, the client's calling us wrong. But do you really know? So if you can extend the trace all the way out to the front end, that's really valuable because both teams could look at the same data in the same tools and not blame each other. They could actually get to the answer quickly. And that's why I joined Honeycomb, because this exists. And they were launching it when I was interviewing. I'm like, oh, I'm definitely coming over now because I'm a Java developer who's worked for years on the back end and went to go bald slowly by using front end code. See, it's almost complete. So I learned AngularJS, Angular React, and Next.js. I'm like, this is the end of this. So then I went and joined Honeycomb so I could talk about all these things and not have to write code. React all day. But yeah, front end is hard. In some ways, front end coding, I think, is harder than Java coding in a lot of cases. It may not be as valued out there sometimes because they're like, that's just the front end. But it's really complex. There are a lot of really strange patterns you have to deal with. So because of all that, telemetry is really useful in the front end as well. And if you can tie them all together with a trace, fantastic.
Your front-end developer is clear.
I know. I didn't do that. This is funny too. We noticed it. So Jessica Kerr and I work with Jessica. She's my boss, actually. If anyone knows who Jessica Kerr is, she's a fantastic speaker. I'm learning a lot. Even though I thought I was really good at this job, I'm not as good as she is. She's amazing. But we were looking at the slide yesterday. She started bursting out. Did you notice that the server developers all have collars and the front end developers all have t-shirts? What's going on? So, and this was my prompt. Create a cartoon where front end and back end developers are yelling at each other on either side and they're throwing code back and forth. once on ChatGPT. I'm like, well, that's done then. I've solved it. But that is kind of the problem, right? That's one of the problems out there, especially in highly striated teams where they say front-end developers over here, back-end developers over here, because how hard is it to train a full stack engineer? And can you keep track of all that forever? Everything moves at different rates. So in a lot of companies, they separate them and then they have separate tools. Yeah, you're running a library in the browser. You're running an OpenTelemetry for JavaScript browser version. And it basically runs on a timer where it collects telemetry and then sends it. Collects it and sends it. Yes. And it's still OpenTelemetry. It's still using OTLP, the OpenTelemetry line protocol. And it's sending it to Honeycomb, or a collector. It's another term for a place that receives telemetry. Honeycomb is also a collector. It collects information. So yeah, they're all running Honeycomb, or they're all running an OpenTelemetry collector. So how do we do that? We do it by installing, we could install the browser one, the one that's like the standard OpenTelemetry browser SDK. That does, we can manually, have anyone here ever built Spring Security applications many, many years ago? Does anyone remember Spring Security? A CG? Okay, if anyone's been around long enough, their hair on the back of it, just stand. Because there were a few people that knew how to do that, but it was by hand. It was like doing a ton of Spring needs. So OpenTelemetry itself, the OpenTelemetry browser library, you can set up OpenTelemetry and send stuff from the browser. And you can certainly do that. Not saying you shouldn't. We are members of the Cloud Native Computer Foundation and part of the OpenTelemetry project. We have a number of people that sit on the committees and we contribute all the time. And because the browser tier of OpenTelemetry is still kind of being finalized a lot of ways, it's still kind of like a development level spec. We can get out front of that by putting our own library on top of it and sending spans that aren't quote unquote standard yet. And then help influence to move those into the standard. And that's what we're doing right now. So when you use our library, you're using OpenTelemetry, and it's an open source library that we have on top of it that you can use. And it just sets it up for you. And it adds all the instrumentation that you probably want. So for example, this is our project, simple library. Find the actual line here, read me, thank you. Here are the things that we automatically instrument when we set up the telemetry for you for a browser. So we put all the browser information fields in by default. Make it easy to send to Honeycomb, but you can send it to any other collector. There's a sampler built in. So if you want to only send every 10 messages, only every 10 spans in, you could say 1/10, right? Give me only so many. That's one of the topics in OpenTelemetry, by the way, sampling, because there's so much data that could go in. You end up having to figure out, do I really want every single span to go into it? Every single thing create a trace? Maybe I don't. So maybe to control your volume, you only take samples of it periodically. So there's a sampler. We have multi-span attributes, or attributes that live on multiple spans. Session.id. Session ID is a unique number, a UID that we generate. We generate that when you log into the page, when you start your app on a browser. I just had a change put in. Thank you for that. That lets us generate it ourselves in code. So we have a little piece of the framework that lets us create a callback where the developer themselves can decide what the session ID is. So that can link up to like a server session number that you might care about, for example. By default, it's a UUID. And so other things as well as a debug mode and automatically enabled web vitals and error instrumentation. So there's a catch-all error method that if the app blows up completely, it'll generate and record an exception. So if it blows all the way up where you get a screen, it's like, that should generate one. And core web vitals are automatically turned on by default as well. So you'll get, how long did it take for the first ping? Oh, there was a cumulative layout shift in this UI. So I record that. So you use that because it's easier than doing all that by hand. But you don't need to. We actually have one customer that looked at our open source library and said, thanks, but we'll do our own. We don't care. As long as the telemetry comes in with the properties we care about, we can show some of our dashboards the right way. but you're not required to use that. So that's that library, and we use that for OpenTelemetry on the browser. Whoops, stop. Here's a real simple example of the front end. So if you've loaded the library in your browser, on the beginning of your component for the first component, you just basically create a Honeycomb Web SDK, give it the name and service, tell it what instrumentations you want. So by default, it will give you fetch, XML HTTP requests if you've got an older like Angular app, browser load information, and then user events. Those come in automatically, and core web vitals if you don't turn them off. Then you start the SDK, and now when you're doing things in the front end, it will trigger sending spam. To get more specific, we can also say, let's set some defaults when we set these services up. So one of the things is, this seems like a really counterintuitive term, ignore network events. But it's like, send a message, got a message, didn't receive a message, NAC, ACK kind of stuff. I don't want spans for that by default. I think they're trying to make that now the default that it's ignored in the standard. But we just give you samples that turn this off, because otherwise you get a ton of traces and a ton of spans you don't need. Then the other thing is, maybe you want to tell it only propagate your trace headers to certain places you send messages. Maybe you don't want to send your trace header to core Google Analytics. So please don't send that out there, right? So you can tell it only the ones that match this regular expression will be the ones that get the trace parent in their outgoing messages from fetch or XML HTTP. So those are some knobs you can twiddle. And then you can use those defaults when you set up your instrumentation. So here's the actual provided, changing the provided stuff that you want to change. So I am going to use instrumentation fetch, but I want to turn off those network spans. And I'm going to allow it to go to anywhere, because I just said globally everything, ./b. So that's my same thing with document load. Please don't give me big network spans for stuff I don't care about. An XML HTTP request, if I still have a library like Axios or the Angular HTTP service, they both use the old style XML HTTP request by default. So if you have that, you can turn that off. That was the sample chunk we had. And then there's another one called user interaction. And this library will record things like clicks and submits and mouse move. Don't use mouse move. Imagine the spans you're sending when you're moving a mouse. Don't do that. So it will do a few by default, but you can get in there and turn on specific ones. So that's an example of some of the things you can do. It's not everything, but some of the things you can do there. Now, how do we send data? So let's talk about how we're sending data if we have browser telemetry too. And I know we're going to run out of time. If we have browser telemetry too, then it has to send telemetry data on the web. Right? If you're doing web service telemetry, like microservices, great. You're behind your firewall. Fantastic. Send it. Right? But if you're in the browser, that means anyone can send it, right? So we have a Honeycomb API key. We let it bounce off if it's not from, it's not a legitimate license. So when the browser sends telemetry, if it doesn't have the right Honeycomb key, it gets rejected. That's how we handle that. I mean, it knows. We let everyone, any browser. Yeah. If the key has to be in the browser, these can maybe be transpiled, right? They may like press code, a string, and the Honeycomb API key is a string. So if you search long enough, you'll find it. But we don't recommend doing it. This is the point, though. When you make a call with browser to a service, trace parent goes this way, then the service that's instrumented is going to continue with a span, et cetera, et cetera, et cetera. They're all going to go to Honeycomb here, but the browser span is going to come in publicly. Okay. And yes, I would not recommend, in fact, our code doesn't do that in the sample, so you're welcome. So the sample I have is we're using OpenTelemetry collector instead. I'm giving you this code as a sample to look at. It's not that much more complicated when I explain it, but browser still does call to the service. It still uses the trace parent header to propagate the trace ID and the span ID from the browser, click or whatever it's going to fetch. Those traces will be sent, but instead of sending them directly to Honeycomb with an API key, we open up a web-only collector. So an OpenTelemetry OTel collector is a standard that everyone in OpenTelemetry service supports. The collector is the special middleware glue that you can install, service you can install, or you can do tons of cool things. You can do really intelligent sampling by having what they call tail sampling. It'll watch and wait until the scan is over to determine whether or not they want to store it. So maybe you want every 10 of them. Maybe you only want some of them based on the kind of things they have done. Collectors are really powerful, and it's like at least one half of the game. Lots of good stuff. You're going to learn about pointry, the collector. Try those stuff you can do there. You can also send different things to the services. You can say, I only want my traces for Honeycomb. I want the logs to the problem. Each one. There's a whole collector contributor library on this. One of the things we just contributed to it was if you build source maps for your browser code, you can upload those in a place where the collector can see it, and then you'll get completely unminified stack traces. So the point I'm making here is notice there are two OTel collectors. One inside your network is going to be really powerful, and it's going to be seen by everything only in your network. And the one that you make it visible to the outside will only deal with web telemetry. And you can turn on CORS headers and things like that and say only as long as it's coming in from this client domain when you run the app, which can be faked. But it's just another level of security. If you do that, the API key is in the collector, not in your front end. So if you look at the config when I give you the code, and you look at the OTel collector folder, you'll see a config file for it, a YAML file, and it says Honeycomb API key as a header, right? X Honeycomb team equals Honeycomb ID. And it will do it on the server side, so you never have to bake it into your client. That also means if someone figures out the key, then you just build a new key and you upload your collector with a new key. And that's for any one of the vendors to do things. So an OTel collector, curious what a collector config looks like. I'll just show you really briefly. So what I'm talking about here is the OTel folder. Nope, that's not the right folder. I'm sorry. I'm in the wrong editor. Cursor. Oh, why did I do this myself? Hold on. Just take a second. I'm a little frenetic. I'm sorry, especially later at night. Okay, so here's my project, and I'm gonna close the OTel collector. This is the config file. This is a standard. This is not a Honeycomb thing. The OpenTelemetry collector is configured through a YAML file. YAML. You can tell it to receive data on gRPC format, the older format, binary RPC format, or OpenTelemetry one. So in this one, we're saying, sure, listen on any network address I have on this Docker container, because it's running in a Docker container. On port 4318, which is pretty standard OTLP port. The gRPC common port is 4370. I did configuration. Then I'm saying I'm going to turn on CORS checking. So with CORS common object requests something or other, what it does is it checks to see what hosting, what origin you came from, and if you have the right headers in there. And if you do, then it will let you in. If not, it'll reject your traffic. Give you a CORS error, which you've probably all gotten at one point. Scratching head said, what is this library for? Me too. I have a blog post on Honeycomb explaining this and showing you how to troubleshoot. But this is basically saying this collector will only receive traffic from the browser came from the 100. Okay, that's an Angular app. 5173, that's a Beat app for running React. Here's a Spring app, and there's another Spring app. I was running it locally to debug it. I'm getting really lax here and saying, whatever header you want to send in, we'll just say you have. But you can be very specific and say, I only want these headers to come through. So if you come through with the right CORS headers, you're in. Then there's processors. One of them is called batch. The batch processors are where you can say, okay, process this many at a time, do it in a buffered way. There's different processors. There's a processor to let you write some language to evaluate each message as it comes in and transform it and change the spans around and modify what you're putting in the collector. Drop things, summarize things, aggregate things. And then exporters. Where's it going? There's a debug exporter. You can print out the telemetry. You can get really detailed about it. It'll give you all the packets and say, this is what we got. This is what we're going to send. Another exporter is OTLP. I want to send this to a server that supports OTLP. Honeycomb, Jaeger, whatever. Endpoint. There's my Honeycomb API key. So the collector has it. I don't care about it anymore in the browser. And what kind of telemetry do I care about? Logs. But so yeah, it's there. I want to, for example, for the service pipeline for traces, can receive OTLP, will go through the batch processor, and it will do the debug output and send the OTLP to Honeycomb. It's just the language to configure ins and outs, right? And processes. Same thing for logging, for metrics. If those are turned on, you get those things. I know I'm almost at time, but there's the symbolicator example. So if I have a symbolicator processor configured, I can tell it, look for my map files from my front end in this folder on, let's say, Amazon S3 or Google Cloud Bucket. So when I do a build, I can upload things to those locations. And then when I get a stack trace, it'll tell me in the compressed file, these are the map file names. Collector will find that, grab the method name for all the stack trace entries, and send a reasonable trace to the collector with really good information for the stack. Now, I don't went through 10,000 things, so I apologize in advance. Well, no, I apologize later in advance. I apologize now. But I guess what I'm saying is I'm all fired up about OpenTelemetry because I think it's a really interesting way of monitoring things. And there's a lot of people working on it, which means it's got a lot of focus. So I will make sure Michael gets the repo, our slides. I'll answer these questions that we have on here. And you can always reach me at Ken Rimple at honeycomb.io. If you go to our office hours, I'm available for a 30-minute thing for free. If you're looking at Honeycomb, you want to ask questions or just OpenTelemetry in general, and you want to ask questions about it, you can reach me and just put yourself on my calendar. I'd be happy to talk to you. Mm-hmm. Yeah. Right. So you can always have a free account to learn it and to use it for smaller applications. You have 20 million events per month, which sounds like a lot until you send a lot of traffic. Because you can send a lot of traffic. So if you keep your traffic small and you have a small test app that you want to use, we're not going to bill you after the 20 million events. We're just going to throttle it. Okay, so we'll pull back on how much we're going to send you. So you can sign up for a free account and you can use it for whatever you want to. We don't license per server. We don't care where the telemetry comes from as long as you send us a valid API key, a service name that matters to you, right? And you point into Honeycomb or collector. Doesn't matter. So we don't put any kind of restrictions like that. We do it on volume. And if you do run out of that and if the professional plans are expensive, you can use Jaeger or something like that too. You can use an open source one. You'll find that the tooling is different. You will see traces. The UI for the traces is different. So we pride ourselves on trying to be as user-friendly as possible, which is why we're commercial too. So we can get paid to do it so we can keep doing it. But you can use open source tools too. And I encourage you to try that as well. Okay, well, thank you. Hey, did you know it stayed the whole time? It stayed up the whole time.
Need to go finish up the slide.
Oh, yeah. Go back to share. Sunny or share, which one?
Sunny.
Wah, wah. Bad jokes start now.
Getting late. That's what.
It is. And I just get dumber when it's late. That's what I mean. So what was that again? It was
The reveal.
Because the flash reveal content.
got it. There it is.
And, hang out for a few seconds more here. Just to finalize. I'll finish up the pizza, please. Otherwise,
this
I'll
is
have
you.
to eat it. We don't need that. Yeah. All right. All right. So, let's see. Oh yeah. Okay. All right. So, real quick, some upcoming events. We have the Code Remix Summit in Miami. You can get a discount. Using that code over there, 75%. That's pretty good. The InfoQ Dev Summit Boston is in June, roughly the same time as last year. I know Mary and Alexander went, right? So we got. I'll have to ask if they'll offer free tickets, so and give them away. So that's coming up. What else? The Kansas City Developer Conference, hot off the press. I did ask Billy Corando if they would provide a discount. So they have that code right there. This is in August, mid-August in Kansas City, if you're interested in going out there. Also, 2 free tickets I can give out. I'll start thinking about that. This is all within the last couple hours. Billy got back to me on that, but I thought I'd advertise the discount over there. So Dev 2 Next is in late September into October, and this is in Colorado Springs, Colorado. This is another conference organized by Venkat Subramaniam. And I have the other ones coming up, QCon San Francisco in November. Hot off the press too is QCon AI. There was a QCon New York, but I knew there was something coming for New York, smaller, and this is going to be an AI conference in mid-December in Manhattan. So stay tuned for more information on that. This should be pretty good. So yeah, I'll have to update those. All right, upcoming events for us. Next month we have Phil Chung from Oracle, who's going to talk about regenerated RAG. I keep forgetting what that acronym. Whatever you guys said. Yes. So with in-memory Java microservices, I'll have to memorize that one of these days. So that's May 13th right here. Same bat time, same bat channel. And bug-free projects with Elliot Rusty Harold on June 10th. We actually had online or almost Nicholas Frankel, who used to be with Hazelcast. He was going to come a week earlier, and then his situation changed, and he couldn't make it out. So we almost had two meetings in June. And then I mentioned Billy Corando. He'll be back, and we have chosen why developers should love testing. So that's on a Wednesday, and Billy's going to make the tour again of Philly, us, and New York. I don't know what order yet. And that's it. So this was, speaking of AI, Barry Bird generated this because I'm a craft beer enthusiast, and Barry is a chocoholic. So anyway, so that was a great picture right there. And that is it. We'll see you on May 13th. There's also something Frank Greco is offering. I was going to put it on the slides, but I'll send it via email to everybody. So make sure you're on my list for that. This has to do with his AI course that he has on LinkedIn. They're letting folks use it for free. It's about 90 minutes through the end of June. So I think that's a great offer. So I have to get some time myself to do that. So and that is it. So we'll safe travels home. We'll see you folks on May 13th.